Thank you very much. I would like to talk on the topic of remanufacturing from the perspective of its contributions to the circular economy. I'm René Van Berkel. I represent the United Nations Industrial Development Organization at its regional office in India. UNIDO is the specialized agency of the UN system that supports the developing country member states to industrialize. We have been more than 50 years in India working on technical areas in support of MSME development. Right now, we are focused very much on inclusive and sustainable industrialization, which is linked to the Sustainable Development Goal 9. So we're talking about inclusive and sustainable industrial development that brings economic competitiveness, creates shared prosperity, and sustains environment. So it's industrialization that works for markets. We have products that can be sold are sought after in markets. We take care of people with decent work, and we observe the planetary boundaries with taking care of environment and climate. We are certainly building back from the crisis that has been caused by the pandemic, and we see that this will likely result in a new normal for manufacturing systems. So we see transformation of global production and consumption systems, which might be driven by three main drivers or overarching concerns. The first one's being resilience, focusing on the interconnectedness in the value chains, and we might want to see companies to de-stress or de-bottleneck their supply chain so they are less dependent on international supplies. And we see digitization. We have actually witnessed a quite rapid uptake of digital solutions in the last 4 to 6 months, and this might also proceed further on, so more Industry 4.0 related solutions. And last but not least, a transition towards circular, or I would say that circular or green environment and sustainability initiatives. So coming to the circular, the basic driving force is that we live beyond planetary means. So if we take the ecological footprint as a measure of the total environmental impact, we see that we currently use about 1.7 planet Earth a year, and that of course is not sustainable. As of about August, we are using resources which are meant to be used in the next year. So we need to address that, and that is highlighted in the concept of economic or resource decoupling economic development from increased natural resource consumption and aggravated negative environmental impacts. We're talking about doing more, so creating more economic activity with less use of resources and economic environmental impact, and for more human well-being. We can then see different interpretations of the circular economy. So on the one hand side, we see the Ellen MacArthur Foundation coming with the more physical model and saying that the circular economy is restorative and regenerative, so it gets away from the take, make, and dispose society to take, make, use, and reuse society. So circular materials to regenerate natural systems and to design out waste and pollution. We see also other interpretations, particularly by the World Business Council for Sustainable Development, that say that circular economy is a new way of looking at relationship between markets, customers, and natural resources. So it looks at new business models and disruptive technologies to transform the linear towards a circular economic model. So if we look at this interpretation, and basically they're talking about 5 business models combined with 3 disruptive technologies. So the 5 business models are circular supply, so using renewable materials and energy, product as a service, so no longer the ownership of a product, but utilizing the service it's providing, resource recovery, so that's recycling and recovery of materials at the end of the life cycle, a sharing platform, so increase the intensity of use by having multiple users of the same product, and product lifetime extension is extending the working life of products. That's combined with disruptive technologies, which are particularly around digitalization, physical, mainly nanotechnologies, 3D printing, and biological or biotechnologies, but also enzymes and related bio-derived technologies. Circular is recycling according to something. We have the 3 R's: reduce, reuse, recycle. That has become the 6 R's, with adding refuse and rethink and repair. That has become the 12 R's, where remanufacturing surfaces. But above all, I think that the circular does not equal recycling. It's much beyond that. It aims at zeroing out waste in the design phase. So that brought us already to the topic of remanufacturing. So if I take a dictionary definition, then it is to manufacture into a new product. But this can also have different interpretations, and I think the American National Standards Institute has come with a definition that states it's comprehensive and rigorous industrial process by which a previously sold, leased, used, worn, or non-functional product or part is returned to a like new or better than new condition from both a quality and performance perspective through a controlled and reproducible, sustainable process. So the key part is that it becomes an industry, so it's done in a replicable manner, and you get a quality at least equal to the new or better than that. So coming back to circular economy, there's a good business case for this. The World Business Council expected that the circular economy presents a 4.5 trillion business opportunity by 2030. There have been different reports by the Ellen MacArthur Foundation for India and China. So in India, it could be about $218 billion annual value by 2050. That is about 8% of the economy. Reduction of greenhouse gas emissions by 23% by 2030, and equivalent of 22% share of the total SDG opportunity. In China, the opportunity is slightly bigger because of its larger scale of the economy, and you might also see there more middle class lifestyle for more urban dwellers, and reduction in traffic congestion, and reduction in air or improvement in air quality. I think that from a manufacturer perspective, we often say that this is an innovation agenda, the circular economy. And I would like to highlight that with the three notions of resource shift, so maximizing the substitution of non-renewable materials and resources by going renewables, then looking at resource efficiencies and improved efficiency of the use of all resources, and then the perpetuality or circularity of value recovery from all waste. So let me elaborate on each of those three with a few examples. So go renewables, that is basically resourcing man-made systems, so industrial systems up to nature's capability by using nature as an input. So using renewables instead of non-renewables as material, energy, water, land, biodiversity, and at rates which are comparable with the natural long-term availabilities in nature. But we can also look at nature as a mentor, so model man-made processes on the basis of natural processes. And that's typically the area of what is known as biomimicry or green chemistry and green engineering. Just a few examples. So using renewables might also be opportunities in the areas of solar heating. So you see here advanced dryer for fruits, vegetables, and spices, or you can look at the same solar heating of industrial process, because we can use this concentrated solar thermal, which can achieve temperatures up to 350, 400 degrees, and which covers 52% of the industrial heat use that can be potentially substituted by solar thermal energy. Using nature as an inspiration, we can look at water purification systems without chemicals or energy, just making use of materials, using enzymes or biocatalysts, for example, for production of antibiotics at room temperature, so no need to cool or heat up, without solvents and at higher efficiency. Or this company which has engineered flames in a horizontal way, which improves heat transfer and saves 30% of fuel. So these are really examples derived from nature and replicated in industrial products. So then the second strategy is this relentlessly practicing efficiency through what you could say resource efficient and clean production, which UNIDO and other agencies have been promoting. So it starts with improving the efficiency of use of materials, water, and energy, so more dollars per kilogram of material or per kilowatt hour of energy. And if we do that, we have less stuff which we can throw into the environment, so we have less waste, effluents, and emissions. And if we do that, we improve the working conditions, occupational and community health and well-being, and that adds to improved productivity. We can say this is a virtuous, self-nurturing synergy that we can establish with resource efficient and cleaner production. So if we look at that, is RSCP as a different type of solutions. Can start with simple housekeeping opportunities, or it can also go into more advanced technology changes or better process control or useful byproducts. This is quite well established technology, and basically this is 8 different lenses by which manufacturing process can be improved. Just a few examples from UNIDO's work, Kanpur leather development project, which was completed in 2018, and then we introduced some new technologies, clean leather technology, so alternative to hair removal from the skins, which reduces then salinity and effluent load by 30%. Here you see installation of water measurements and which monitoring of water use, which leads to 20% water consumption. And then here you see some solar dryers, so we can save 10% of energy by air drying of the leather. Then the third one is the perpetual recycling, and that is basically looking at how the man-made system can be incorporated into the natural ecosystem. And that is basically a multi-pronged agenda to recover value from previously discarded waste. So full recovery of materials, water and energy in all life cycle stages, with the purpose of perpetually retain the man-made materials in the man-made systems. So things which we have synthesized and which are not natural should be kept in man-made systems, and things we have borrowed from as natural materials from the environment we can return and let nature absorb them there. We need to take, of course, care of the environmental risks. And particularly, we have a high material complexity of the different waste streams. And then, of course, we need to look at the conducive policy frameworks for that. This is also already done. I just take a few examples from textile first. If you see Arvind, denim manufacturer in India, they do already 70% water reuse, 50% of their fuels is organic material, and all the new jeans are 20% recycled fiber, and they do salt recovery. Or you can go with this no waste t-shirts, which are 100% post-consumer recycled knitwear. Or we can look at creating wealth out of waste, and there we have Saatchi Eco Innovations that produces biodegradable sanitary pads from just waste banana fiber. We have Aspartica, which produces omega-3 fatty acids, which are a nutrachemical from the waste that is left over after you extract the silk from the silkworms. And then we have Brazil, which is extracting its silica additives from rice husk ash, which can be added to tires to reduce the rolling resistance and save energy when the car is driving on the road. We can extend this reuse and recycling into industrial parks, where basically we say that we optimize water and energy use and reuse between companies in industrial park, or we look at using secondary resources from industries, from cities, from the region into industries. And that is the work of area of eco-industrial parks, which UNIDO and the World Bank and GIZ have provided guidelines for and which can be utilized. I will want to then maybe as a last input refer to the work of the International Resources Panel, and they talk about remanufacturing in the context of value retention process, or VRTs. And they say that if you look at new manufacturing, it's manufactured and then it goes to end of life. If it's remanufactured, it goes to end of first use and then be remanufactured to a new end of use, and then maybe after several end of uses it becomes end of life. If you see refurbishment, it is also extended, but it might have lost some of the functionality, minor loss. So these are full value retention processes. And then we have partial service life retention value recovery processes, which is where you have at end of use, you arrange for direct reuse. So you extend the useful lifetime before it's being disposed of, repaired, and you basically after manufacturing you undertake some repair activities, and refurbishment, which is a more limited form of extended value lifetime. So they looked at 3 case studies on what is then the impact. So they look at vehicle parts and heavy duty equipment parts. So that is for tractors and excavators, and then at industrial and digital printers. And they found that the greenhouse gas reduction of these value retention processes is in the range of 79 to 99%. Material conservation is 89%, and remanufacturing can go up to 100% with reuse. And then the cost savings are estimated, but very different between different products, 15 to 80%. Overall, it seems that this value retention is enabled by innovative business models, which include product service systems, products as a service, sharing economy. This was basically the new business models which the World Business Council was talking about for circular economy. And it's driven then, of course, also by new product design process and priorities. So you make, if you're looking for value retention, make something durable, upgradable, and it's something that can be easily repaired. So I would like to come to a closing and say that the circular economy can mean different things to different people, yet goes always much beyond recycling. It's not recycling or recycling plus. It is a way of design. It is designed in and provides a new lens for business, product, and process innovation. This may then involve or be achieved through remanufacturing, which I would say as industrialized, what we know as repair and refurbishment practices. Industrialized and meaning that it is a quality, replicable, it's decent work, and it guarantees at least equal, if not better. And that we see as we promote manufacturing, we should also promote as a natural twin the remanufacturing approaches. I apologize for having to go relatively quick through this. There are more materials available in the different initiatives that UNIDO is part of. Overall, I think that remanufacturing is really a key opportunity that should be looked at in terms of both transition to a circular economy as well as establishing a world-class manufacturing hubs. Thank you very much.